this first one's almost like the first one we did. Basically, it's the same thing, but where do I find first?
Zeros?
Yeah, so let's be 0 about right here. Radar. And then, of course, it starts off, slope starts off how?
Positive.
Big positive, right? So I got to start it way up here. And of course, it's getting less and less and less positive until it gets to 0. So that's exactly what I'm going to do. And then it does turn and become negative. And I know it's going to go back to 0 here. So somewhere in the middle here is that interesting extreme slope, right? So right about here, maybe, is where it's going to have like the biggest negative. So that should be right where you hit the bottom out of your one you're drawing right there. Right, if it's the biggest negative, then your line you're drawing should be at its lowest point. And then it comes back up because now it's getting less and less negative until it's 0 again. And then after that, it's going to be getting bigger, bigger positive. All right. Now this one we already did. So here the slope is -1. Whee! Open circle. And then here the slope is +1. Whee! And of course it's both open circles because right at that point there is no derivative or lockups. Number 2 shouldn't be too evil. How many places are there? 3. And of course they are -2 because that's a cusp. Where else? Yeah, that's another type of cusp. And then finally, 3, because that had a jump discontinuity to begin with. Jump discontinuity. So the slope is going to freak out. Now, let me, is everybody cool with that one? That one shouldn't have been too evil. That's a nice question. Let me go back up here real quick. Would the picture we drew, would it have changed? How would it have changed if I took this and just moved it down? If I just took this black, the original, and I just took it and just moved it down, I like translated it down, what would have happened to the blue line? Not a damn thing, because the blue line captures a slope, and if I move that down, the slope change? No. So if I told you a line has a slope of 1, could you graph it? Could you graph the exact line I'm thinking about? Have I given you enough information? No. Do you see what I'm saying? That's why on number, 2, 2 the sequel. That's why I say sketch a possible function, because you can pick where to put it. I would pick somewhere where the thing would fit. I don't know if you guys quite see what I'm saying. So it's just like if I gave you this blue line and I asked you to graph the black line, you could have put it where. What has to happen right there? The slope has to be 0. Why would it have to be a peak there? Couldn't it be a peak down here? If you felt like it? It just has to peak there, doesn't it? Doesn't have to peak there up at near 6. There's nothing there that says that. So it's the exact same idea as me giving you the slope of a line is not enough information to graph it. I also have to give you a position, and that's what's missing. If I give you the slope function graphed, it's like me telling you the slope of the line is 1. Is that enough information to graph a specific function? No, but I can at least capture the shape of it. I like it. If somebody then told me, oh yeah, g of 2 is 7, then maybe I can get the whole thing in the right place. I need more information for that. So that's why it says sketch a possible function. So that's part of this. Now, and it's all about shifting gears very often. I can sometimes see smoke coming out the ears because shifting gears between this kind of problem and this kind of problem, it's not simple. But you got to keep reminding yourself what the thing is telling you. So what am I being told right here? What's true about G? Yeah, the slope is constant. right? The slope is 3. That's what it is. I just know the slope is 3. So what would G look like? So for example, I can pick anywhere to start at. So I'm going to pick down here because I know the slope is 3. I want to give myself enough room for this to fit. Does that make sense? I'm not sure exactly what your attempt looks like, but I don't blame you if it's not quite right. So I'm going to start, I don't know, down here. My slope is 3, so I'm just going to go 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. How do I know this is a straight line? Because the slope doesn't change throughout that whole interval. The slope doesn't change. That's a straight line. So that's part of it. Now, if I want to I can make my function continuous if I choose to. There's nothing here that says it has to be honest. But now the slope, what's going to happen now? Yes, now it's going to be flat. That's easy. Now this is where students kind of don't focus on the right thing, but this is, I can totally, from here to here, I just have to put a flat line. Because the slope is 0 between those two. Okay, maybe. Normally the slope is 0 for a nice curve just at a single point, but here it's 0 throughout an entire region. Yay, that's a horizontal tangent line. Just continued for a while. And then what happens to my slope? -2. And again, it's a choice I've made. I'm going to try to make the result continuous, but you didn't have to do that. So now I just got to go down 2 over 1. All right, so -2 slope down? Down 2 over 1. And of course, now my slope becomes 1, so up 1 over 1. So there's one possible answer. The shapes you would use in a correct answer should all be the same shapes I did. But they don't have to connect necessarily. But that's a decent, to me, that just keeps me, I'm going to make it continuous if I can, just to keep it straight in my head what's going on. You guys cool with that? Is that, maybe? Okay, that's pretty good. If that's true, it's pretty good. What about this one? Is the slope 0 anywhere? Yes, where? Careful. Say again. Where's the slope 0? -3 and 3. Remember, this is the G prime already. This is the slope. So this is going to be a situation where at those points I'm going to have a peak or a valley, right? Depending on what the slope's doing around it. So what's the slope to start with? Positive. I love it. Getting smaller. All right, so maybe I'll start up here. And right here is going to be like a little, this is where the slope's got to be 0. Right? So slope is positive. Getting smaller until it gets to 0, so I can go like this. And then it becomes negative until it's right here. Now, I could be a lot more, now to be honest, I could be a lot more precise, but on these kind of problems, I don't need you to drive yourself insane trying to make it. See how right here it's supposed to have a 1 slope right here? And so forth, but I mean and then every step you take, it changes a little bit, so that could drive you slightly mad, on top of this already being a difficult problem. So I'm not going to be overly picky about the exact value of the slope at a point. I want the general idea of where is it 0, is it positive, is it negative. What happens right here? Now the slope, For this one, I might be a little bit, because now it's just got a -1 slope all the way through until here, right? So it's just going to be bam, bam, bam. Is that cool? It's got a -1 slope, so I mean that's got to be pretty much aligned with a -1 slope. That's easy. That's not too bad. It's not a changing slope, which is harder to really capture. And then, of course, what happens here? What happens right here? So right between these two, what's going on? Yeah, right here is where it changes from negative to positive. But in here, it's getting less and less negative, so it should start to like turn. That's a place where it's 0, right? So that should be a valley. Is that cool? So it's kind of like the opposite of what we do when I'm given the function and I'm trying to graph the derivative. Here I find where the value is 0, and that's where that peak is going to be. The other way, I look for the peaks and I put the zeros there, or the valleys, I put the zeros there, right? And then what happens after this point? The slope becomes positive up to there. So something like that would be fine. In fact, you didn't have to start here. Why did I start here? I don't know, just because I wanted to. You can have this shape anywhere in here. Right? Because that's what we were talking about earlier. There's not enough information to know where to put that. I just know what the shape should be. Is that decent? Okay. All right. Don't worry about the back of this one yet. The back of this one is chapter 3. We're going to talk about that yet. Let me give you the... Oh, whew. I thought it was dead. Let me give you the other one. This is actually from 2.7. This is stuff we talked about already, but I want you guys to try it out. Start on the side that's got, let's see. Yeah, start on the side with all the graphs on it, stuff like that. Try that side out. Kind of nice. It kind of comes right off of what we were doing. It's a little bit easier than what we were doing, actually.